Hello there! This video gives you an overview of different measures of reliability and validity in construct measurements. Because many of the measures used to assess reliability and validity involve correlation coefficients, I'll spend a little bit of time at the beginning of this video going over how to interpret correlation coefficients. Then comparing the difference between what reliability and validity are more generally, and then looking at specific types of reliability and validity in construct measurement, and then finally some of the threats to those measures of reliability and validity in construct measurement, and how to avoid those threats as well. So let's kick off by taking a look at strength and direction of correlation coefficients so that you'll be better able to interpret measures of reliability and validity. So there's two different pieces of information in a correlation coefficient. One is direction and one is strength. So let's start with direction. So if you see a correlation coefficient that is positive value, it's not negative, it's positive, that means that the two variables that are being measured or assessed tend to go in the same direction. So that means that those who have higher scores for variable x tend to have higher scores for variable y, and then those who have lower scores for variable x tend to have lower scores for variable y. So x and y tend to go in the same direction. If you have a negative value for a correlation coefficient, that means that x and y tend to change in the opposite direction. So those who have higher levels of x tend to have lower levels of y, and those who have lower levels of x tend to have higher levels of y. Notice I'm saying the words tends to, and that is to emphasize that if there's a correlation between two variables, it doesn't mean x causes y, it just means there's a tendency there, there's a relationship there. So let's think of some examples of a positive correlation. So study hours and grades, right? Students who study more tend to have higher grades, students who study less tend to have lower grades. Level of education and income, those who have higher education tend to have higher income, lower education, lower income. Also, sense of belonging in college and GPA, right? Students who tend to have a stronger sense of belonging tend to have a higher GPA, and those with a lower sense of belonging tend to have a lower GPA. Also, let's think about examples of negative correlations or negative relationships, those that tend to change in the opposite direction. So number of class absences and grades. You miss more classes, you tend to have lower grades. You miss fewer classes, you tend to have higher grades, right? See that inverse relationship there. Another example would be number of children and savings account balance. If you have more kids, you probably have less in savings. If you have fewer kids, you probably have more in savings. And then back to sense of belonging. Since sense of belonging is probably positively related to GPA, sense of belonging would probably be negatively related to dropout intentions. So those who have a stronger sense of belonging tend to have fewer intentions to drop out, and those that don't feel like they belong in college probably have more dropout intentions. So I encourage you to think on your own about some examples of positive versus negative correlations. The second piece of information that comes from a correlation coefficient is the strength of that relationship. So if you have a value for a correlation that's closer to 1 or -1, that means you have a more consistent relationship. That means there's more of a linear pattern if you look at the data, assuming you're looking at Pearson's R correlation coefficients, which most things are. So remember, negative correlations are going to have a negative value and positive correlations are going to have a positive value, but both positive and negative correlations can be very strong. So if you look at our first example here, if we look at quiz grade and time studying in hours, you can see that there is a positive upward trend, right? Those who have more time studying tend to have higher quiz grades, right? And those who study less tend to have lower quiz grades. If we look at a negative, also strong relationship, right? Very linear, the dots are close together, very consistent. You can see that there's an inverse relationship here where those who do more cardio tend to have less body fat, and those who do less cardio tend to have higher levels of body fat. Weak correlations are any value that's close to 0. And keep in mind that you're never going to have a correlation that is greater than 1 or less than -1. That's kind of the boundaries of a correlation coefficient. But closer to 0 means weaker. It means less consistent relationship between the variables. So if you look here, those that have a lot of siblings, right? Some have a few siblings, some have many siblings. there's not really a clear pattern there. There's not a clear upward or downward trend. It's just kind of spread out everywhere. So now let's think about the difference conceptually of what reliability and validity is, especially when it comes to construct measurement. So reliability is about the degree of stability that's exhibited when a measurement is repeated under identical conditions. So how consistent is it? So lack of reliability may arise from divergences between observers or instruments of measurement or the instability of the actual attribute being measured. Validity is all about how well a measure measures what it sets out to measure. Are you actually measuring what you think you're measuring? So it's how accurate it is, not how consistent, but how accurate. So a scale will reliably give you the same value if you hop on a few times right now, right? If you jump on a scale to take your weight, it's going to give you the same value. But that measure is only valid if you're hoping to measure weight, right? So if you're hoping to measure height, it's not a great measure of height, but it is a reliable measure if you get on it over and over again, right? It's consistent, but it's not actually tapping into what you think it's tapping into or what you're trying to measure. So at best, we have a measure that has both high validity and high reliability, meaning it yields consistent results and repeated application, and it accurately reflects what we hope to represent, right? It's valid. It's possible to have a measure that has high reliability but low validity, one that's consistent in getting bad information or consistent in missing the mark. It's also possible to have one that has low reliability and low validity, meaning it's inconsistent and not on target. Finally, it's not possible to have a measure that has low reliability and high validity because you can't really get at what you want to measure and what you're interested in if your measure fluctuates wildly. So in an ideal situation, you have a measure that's both reliable, consistent, and valid, hitting the target. So now let's hone in on reliability or consistency in construct measurement. And again, we're focusing on quantitative measures of those qualitative constructs, right? Numeric measurements of things that aren't always necessarily numeric in nature. So retest reliability is important for assessing how well supposedly stable traits or experiences are measured across time. So you see if scores on the first test are highly correlated with scores on the same test taken later. And if they have a correlation of around 0.70 then that, or higher, then that is acceptable. So there's some problems with retest reliability. It's very time consuming, especially if you need a large amount of time in between assessments. And it's inappropriate for some types of survey scales measuring constructs that are likely to change over time. So like state anxiety, energy, happiness, things like that. So there's also carryover effects where the pre-test can influence the post-test, or a practice effect where individuals become familiar with the items and simply answer based on their memory of their last answer in an effort to seem consistent. So that can inflate the reliability estimate. But it's still a good way to see if there's stability in what you're measuring across time. Now we have internal reliability. So this is capturing if there are consistent responses for survey items that are supposed to be tapping into or measuring the same construct. So you can see here we have a self-efficacy scale, and you see that there are 4 different items that are all supposed to tap into self-efficacy. So if all the items from the same scale are correlated across all participants, meaning people with a high score on one question tend to have high scores on most of the other questions measuring that same construct, then you'll have a Cronbach's alpha of around 0.70 or higher. The great thing about Cronbach's alpha is that if you get a bad measure of Cronbach's alpha, it could mean that you forgot to reverse code. And so you can go in and you can tweak your coding before you construct your mean scale score for the analysis. So it really helps you clean your data where you can reverse code things that you forgot to reverse code, or maybe even remove problematic survey questions that don't tap into the construct before you create those mean scale scores. So if you look at this example, you can see that our first item here, measuring self-efficacy, if something unexpected happens, I'm not sure how I would handle it, that's actually indicative of less self-efficacy. So you can see here that higher scores are associated with more disagreement. But then these final 3 items are all indicative of more self-efficacy, so higher scores show higher self-efficacy. So if you had this data in this way, and you created a Cronbach's alpha, it may even be negative or very low because you forgot to reverse code this first item. So that would prompt you to get the scaling flipped, because sometimes when you first do the survey, everything is going to be coded 1 to 5. But you have to manually go in and reverse code those negatively worded items. So if you forget to do that, Cronbach's alpha can remind you, hey, that strongly disagree needs to be a 5, not a 1. So it's really useful for that way. So if you've ever seen a correlation table in a journal article or presented in the media, you may see something that looks like this. So what you'll notice is that the variables are all listed here, and then those variables are repeated here as well. So before we jump into Cronbach's alpha, I just want to show you how to read a correlation table. So this data is looking at relationships between high school self-efficacy, workplace self-efficacy, self-esteem, also high school bullying experiences and workplace bullying experiences. So this whole column is pertaining to our first variable, high school self-efficacy. And so here I can see that there are correlation coefficients, and knowing that these stars represent a statistically significant or reliable correlation, I'm going to focus on this one. So what this tells me, because it's negative, right? See that negative there? That those with higher levels of high school self-efficacy tended to have fewer high school bullying experiences. Conversely, those with lower levels of high school self-efficacy tended to have more high school bullying experiences. And I know that it's reliable because I see these stars here, meaning it's consistent, it's reliable. And I know that it goes in that direction because of the negative sign. Let me show you one more. So let's have a look at maybe this coefficient right here. So this is the intersection of variable 2 and 3. And so what we can see, because it's a positive correlation and it's statistically significant or reliable, variable 2, workplace self-efficacy. So those who have higher levels of workplace self-efficacy tend to have higher levels of self-esteem because it's a positive correlation. And those with lower levels of workplace self-efficacy tend to have lower levels of self-esteem. So that's how to interpret correlations in a table. But now let's focus on Cronbach's alpha. So you can see that along the diagonal, we have these values. And it doesn't make sense to look at the correlation between 1 and 1 right here, right? So that is a placeholder for Cronbach's alpha. And you can see that of all these scales, the workplace bullying experiences had the highest Cronbach's alpha, so it was the most reliable, meaning that people who had high ratings for certain items tended to have higher ratings for all the other items looking at workplace bullying experiences. The least reliable measure, the least internal consistency, is for high school self-efficacy. There was more variation on how people responded to those items. Now let's take a look at alternate forms reliability. So this is when you're looking to see if there are consistent responses on 2 different measures of the same construct. And if responses to those similar items are correlated across all participants, then you'll see a correlation around 0.70 or higher to indicate alternate forms reliability. Be sure that the 2 measures address the same aspect of the behavior with the same vocabulary and the same level of difficulty. So really the items should only differ in wording and context. Alternate forms reliability is used to test the usefulness of a measure for a same-day pre-test, post-test, where you do not want taking the first test to impact results on the second test, regardless of the experimental manipulation that took place between the 2 measures. So, for example, you could want to test the effectiveness of an intervention. So you could look at a stats quiz before and after a lecture to see if the quiz had an impact on understanding of stats. So the stats quiz before and after a lecture should be different if you want to truly assess the impact of the lecture on understanding without worrying that students perform better on the second time because they already had experience with the same exact questions. So that alternate forms reliability can be really important when you're trying to create multiple versions of a test too for a class. So for instance, when I'm creating question pools in Blackboard, I have various pools for various concepts, and then lots of questions within those that have the same level of difficulty and tap into some of the same things. So if you have multiple questions and question pools for Blackboard, that can help reduce cheating or allow extra attempts with different questions. So I usually could create 4 questions that assess understanding of a correlation and understanding the direction of a correlation, and then students can just randomly be given one of those questions that are all kind of equivalent and have alternate forms reliability. When you're testing alternate forms reliability, it's important to use counterbalancing to see if test order matters. So you can have half of the class take the stats quiz A first, and stats quiz B second, and then the other half could take stats quiz B first and stats quiz A second. And you see if there's a significant difference in grades on the same quizzes between the two groups to see if taking one impacts the other. Now let's move away from how consistent measures are and look at validity. How accurate are measures? So face validity is the extent to which untrained participants in a survey scale believe that the items are relevant to what they are supposed to measure. So face validity is all about, like, does this look right? Does it feel right? So in employment selection, unfair seeming selection tests can lead to legal challenge if the applicant is not hired. So sometimes in employment selection, you see these veiled purpose questions that are a form of integrity testing in employment selection, and it's designed to tap into integrity without people knowing it. So while these questions may not seem like they have anything to do with the job or do with the job interview that the position or the applicant is trying to earn, so they have low face validity, these questions allow recruiters to make predictions about an applicant's work-related behavior without them knowing it. So for instance, you could ask, how often do you go out to parties? Applicants who answer very frequently may be prone to absenteeism and alcohol abuse. You could ask applicants how often they make their bed, and this could highlight a person's organization skills. You could ask applicants, do they like to take chances? And this could be an indirect way to determine an applicant's risk-taking. You could ask applicants if they feel confident about themselves. So this could suggest an applicant's independence or self-confidence and ability to perform well on their own. You could also ask, when do you feel most lonely of applicants? And this could suggest whether an applicant is a lone wolf or a team player. Now again, these may tap into important competencies for employee selection, but chances are they're going to have low face validity. The person answering those questions is going to be like, why are you asking me this? Another example could be if a quiz didn't seem fair, right? It has a low face validity because maybe it's different than what was covered in class and the study guide didn't help. So you can see that frustrated kid there is like, this quiz is not what we covered in class. So low face validity. Content validity is all about whether or not a survey scale or measure taps into all the content they are supposed to measure. So including everything that it should and nothing it should not. So with content validity, this is like subjective face validity for experts. So it's the subjective judgment of someone with knowledge in the subject matter. So it's really about, do items in a single scale cover all the indicators of the construct of interest? So think about what's missing in this measure of school satisfaction. So I enjoy my classwork. I like interacting with my classmates. What are some other facets of school satisfaction that are important to tap into? So think about it for a second. So some things that come to my mind would be faculty availability, right? Are they available for office hours? Are they coming to class or canceling class? Faculty support, so how supportive are they when you come to them for help? Maybe even the availability of classes and class times, right? That's something else that would tap into school satisfaction. And even the helpfulness of student support services. So you can imagine that this measure of school satisfaction has low content validity because it doesn't tap into all the facets of school satisfaction. There's no correlation coefficient here. It's really just the opinion of experts who know this content area and these constructs well. Predictive validity or criterion validity is all about looking at the relationship between constructs and desired behavioral outcomes. So looking at those relationships between variables. This is a really big deal in industrial organizational psychology, especially when it comes to employee selection, because to survive a legal challenge, you have to be able to prove that whatever tests you're using to select employees are actually predictors of performance on the job. So for instance, you see here we've got integrity tests, so kind of like on that measure we looked at earlier, and performance appraisals. Here you see a strong positive correlation where those with higher integrity test scores tend to have higher performance, and those with lower integrity test scores tend to have lower levels of performance, but there is some variation there. But I would say that this has some criterion validity. Those test scores are predicting performance. Another one that is very common and it is actually up for discussion right now are standardized testing and how well that predicts actual outcomes for students. So the GRE, the graduate record exam, is a really popular entrance exam for graduate school. And research suggests that it's a barrier to entry for a lot of underserved populations, that it is biased towards people who have been raised in the United States and have higher socioeconomic status, and that unfortunately it doesn't do a great job at predicting outcomes for actual graduate students, even though it's used to weed out graduate students as applicants to go to graduate school. So what we found is that GRE tends to be a predictor of first-year retention, but really nothing else. So it has a low predictive or criterion validity. And during the COVID-19 pandemic, schools didn't require the GRE for admission because it was so difficult to schedule an appointment to take the test. And I think that it's a great trajectory because after that happened, they realized they were still getting good grad students, and a lot of schools are getting away from requiring the GRE altogether. Concurrent validity is all about looking at the relationship between new and established measures of the same construct, because the measurement procedure distinguishes between sample members in the same way, not necessarily because it measures the exact same thing. So this is useful for creating cheaper, shorter, or easier versions of surveys or tests. So you can see an example of burnout measures here, where you see the short version versus the long version. And if you have people take these two different survey scales and they're very highly correlated, then you would say that they have concurrent validity. So if the correlation between these two measures is 0.70 or higher, you may be able to justify using the short version of burnout versus the longer version. So construct, convergent, and divergent validity are all concerned with statistically comparing a measure to other measures. So construct validity is the measure of the variable, seeing if it behaves as it should. So is it related to variables that you would expect based on past research and theory? So for example, if you're measuring self-esteem, scores on self-esteem should be related to established measures of self-worth, social skills, confidence, and self-appraisal based on past research. Convergent validity is looking to see if a survey subscale score is strongly correlated, or if survey scores are strongly correlated with another type of measure for the same construct. So for example, making sure that all of the burnout subscales are correlated and converge on an overall burnout construct. And also that burnout survey scores are related to a physiological indicator of burnout. So maybe looking at immunoglobulins in the blood system or immune system health to see if that is also related to your measure of burnout. Discriminant validity is determined by making sure that scores on a survey scale are weakly correlated with scores from a previously validated survey scale, measuring a construct that should not be related to it. So for example, IQ scores that are measuring general intelligence should not be strongly correlated with emotional intelligence, which is a totally different construct. So that now that we've focused on internal reliability, how consistent measures are, and internal validity, how accurate those measures are at tapping into our constructs, let's think beyond the confines of our study and looking at external validity in construct measurement. So external validity, or validity generalization, is looking at the degree to which inferences from scores on survey scales apply to the population of interest. So operationalization generalization is always a concern with predictive versus concurrent validity in employee selection. So will a selection test that predicts current performance among current employees, most with high enough performance, also predict future performance of applicants? So you want to make sure that a selection test that's validated among college students, right, looking at GPA as performance, would apply to factory workers where performance looks very different. Or also making sure that a selection test validated among current employees, right, looking at that concurrent validity, also applies to future applicants. So making sure that tests that you're validating in one sample are going to actually work the same way in other samples that you want to use them in. Now let's take a look at different threats to reliability and validity in construct measurement and how to overcome them. So measure sensitivity is all about how well the measure captures the full spectrum or continuum of the variable. So a good thing to do is to use decimals for ratio variables with a small range. You don't want to limit GPA to 1, 2, 3, or 4.0, but allow people to actually put in the raw value for GPA. When you're using Likert scales, use at least 7 points to measure those attitudes and perceptions so you can tap into the variation in those attitudes and perceptions. It's also important to avoid open-ended scales. So for instance, if you're measuring something numeric, have them type it in numerically. Don't say, how many children do you have? And then give them the options of 0, 1, 2, and 3 plus. That open-ended scale allows you to not have a sensitive measurement of number of children. Also, make sure that measurements have the appropriate level of difficulty for the sample. And this is especially important in testing. So you want to make sure there's some variability in knowledge check scores or quiz scores. So you can see here in Blackboard, it gives me all of these wonderful statistics for my knowledge check questions. And so you want to see good discrimination, and that's driven by more standard error, more variability, more differences, or more standard deviation in those scores. Another threat to measurement is restriction of range. So this determines how well a sample represents the low end, the floor, and the high end, or the ceiling, of that spectrum or continuum of the variable in the population. So you want to make sure that the sample represents the full range of variation you expect to see in the measurement of your variables in the population of interest. So for instance, if I'm testing the predictive validity of a selection test with a sample of new hires, I do not want to use the test to hire employees in the sample, because only those employees with high scores on the selection test would be selected and included in my sample. So I would have no idea how well lower scores on the selection test predict performance in the future. Also, if I was assessing school satisfaction, I wouldn't want to rely on asking students at graduation, because students who make it to graduation are probably more satisfied than the students who did not graduate and were not included in your sample. So just making sure that you're covering the full range of values in your measurement. And this isn't just related to the way you measure it, but also how well the sample represents your variable of interest. Reliability and validity are kind of intense. There's a lot to wrap your head around, but it's important to understand reliability and validity for multiple reasons. So if we know that we can assess reliability and validity and control for it, we can increase the confidence in our own findings and the findings of others, because research is more useful when you're measuring things correctly and you have the ability to draw conclusions about your variables of interest based on your results. It's also important to care about reliability and validity to avoid wasting your time conducting crappy research that will not likely be accepted for presentation or publication. Peer reviewers are not going to accept those types of methods. So you can avoid wasting the time of your study participants and yourself by doing reliable and valid research, because you definitely don't want to waste the time of your study participants who are volunteering for research, assuming their data will be useful and helping researchers have a better understanding of human behavior, or to create interventions that help humans thrive when the methodology just isn't sound. It's also important to understand reliability and validity so you can critique others' research and the conclusions made based on such research, and be a lot more careful about what you're sharing on social media or about ways that you change your behavior or your perception about things based on research. So when you look at the methods section of an article or you read a summary of how a study was conducted, you can assess how reliable and valid those methods were, so that you can kind of take things with a grain of salt maybe if the reliability and validity is low. So hopefully this is not just applicable in your academic world, but also in your non-academic world where we're bombarded with research findings all the time.